Writing exponential equations. First, we're going to look at how to write the equation or the function from a table. So as we look at the table here, we first have to decide what is our start value. Where is that f of 0 or that a value that we look for right here? So going back to the table, start value obviously has to be when the input is 0, and in this case, when the input is 0, the output is 1. So now what we have is y equals 1 times delta x, or using the other format, y equals 1b to the x. Okay? Second part we need for these is that delta, or that common ratio. So we're looking for that pattern. So even if you aren't able to get the pattern from the fraction to the whole number, you should be able to get it from the rest of the numbers. So as I look here, going from 1 to 5 is a times 5. 5 to 25 is a times 5, and so on. So now we know that our delta, or our b, has to be 5. So to finish this off, y would equal 1 times 5 to the x, or we can not worry about the 1, and alternatively you could just write it as y equals 5 raised to the x power. Let's do that one more time from a table. Again, we're looking for that y-intercept. Remember that these values here, that's that y-intercept that we look for. So right here, where x is equal to 0, y is equal to 64, and that's our start value. So we have y equals 64. Now we need to go ahead and look for that rate of change. So I'm going to look for my delta, or my b. That's, remember, my common ratio. And so going from 64 to 16 is dividing by 4. 16 to 4 is dividing by 4. And divide by 4. Since we always express the common ratio as a multiplication, we need to remember that divide by 4 is the same thing as multiplying by 1/4. So we're going to go ahead and put in our 1/4 as our common ratio to the x power. We also need to be able to write these from a graph. The easiest way to do this from the graph is to go ahead and make yourself a table. So I'm going to go ahead and make a table, and I want to think about first, when x is 0, what is y? Well, when x is 0, y is right there at 3. Okay, so we've got that piece. So now I can write y is equal to 3. We know the start value. If we look at the point at 1, 1 seems to match up at 4. 2 seems to match up at 6. 3 seems to match up where we're not going to be able to see it. So this one could be a little trickier, and it's probably not the best example for me to have chosen. But when I go from 3 to 4, and then from 4 to 6, graphs get a little trickier, but from 3 to 4, we are multiplying by 1.3. Oops, sorry. 3 times. So it looks here, again, I didn't do a very good value here, but whatever you were to have picked out for this piece right here would be what goes into this spot to the x power. Again, I apologize for not choosing a good example like I thought I had. Finally, from a situation, and this is where in real life we see this most often. It's used in interest rates for banking. It's used in statistics. Anything where we need to think about how things are rapidly growing or declining. So in 1985, there were 200 cell phones in the small town of Exponential. The number of users doubled each year after 1985. Write an exponential function for the situation. Okay, so we know with our exponential functions, we have y equals ab to the x. We know that a represents that starting value. Well, here it says starting value was 200. So our start value is 200. Then we have to look for that common ratio, this piece right here. So how did these phone users change? They're not going to tell us in the word problem that it multiplied by 2 or it divided by 4. We need to look for words like doubled. So doubled tells us the common ratio is 2. And finally, we can go ahead and write our function as y equals our start value of 200 times 2 raised to the x power. You also may then have to know how are you going to go ahead and use that question. So here's the function we wrote in the previous slide. Now I want to know how many cell phone users were in Exponential 10 years later. Well, the 10 years becomes that exponent. So now y equals 200 times 2 to the 10th power. This is easy. Throw it in your calculator to get an answer for it. Okay, so in your calculator, remember you would use that caret key to get your 10th power, and we would find out that 10 years later, there were 204,800 people with cell phones in Exponential. Let's try one more situation. If a tournament starts out with 64 teams, how many rounds will it take to reach the final game? Okay, what's your start value? It says right here, starts out with 64 teams. So start value is 64, which I've already put in the table right here. We need to think about how sports works. In a tournament, usually it's elimination. So 2 teams play, only one can win and move on. So after the first round, there would only be 32 teams. Half the teams would have lost. After round 2, we get 16 teams left. After round 3, 8 teams are left. Okay, we know our start value, so we can go ahead and write y equals 64. But then we also need to know what is that common ratio? Where's that delta? Well, what's happening over here each time is we're dividing by 2, losing half the teams each time. So 64 times 1/2 raised to that x power would give us the function. In conclusion, as you write your functions, you need to remember to look for what is that start value. In a table, remember you're looking for when does x equal 0, and then what happens with that y value. After you find that start value, remember you also need to look for that delta or that common ratio. Plug both pieces where they belong. So we might have f of x equals f of 0 times delta to the x, or y equals ab to the x.